What's up guys? In this video, I'll be taking a look at the three forms used to represent quadratic functions, also known as parabolas, and I'll be explaining what information each of these forms conveys about the function, as well as how to convert between the three forms. Alright, I'm going to be beginning by taking a look at the standard form. This right here is an equation of a parabola written in the standard form. This gives us some information about the function. So this a right here, which is the leading coefficient, can tell us whether the parabola opens up or down. If a is negative, then that means that the parabola opens down and has a maximum point at the vertex, which you can see here. If the a value is positive, it means that the parabola opens up and there's a minimum value at the vertex, as you can see here. The leading coefficient, or a, also tells us if the function has been vertically compressed or stretched. So if the a value is between 0 and 1, that shows that the parabola has been vertically compressed. And if the a value is greater than 1, the parabola has been vertically stretched. I'll show you guys what I mean by this in a bit while using Desmos. It also tells us the y-intercept. So this c value right here is the y-intercept. So for example, this function right here, written in the standard form, opens down since the a value is negative. As you can see, there's a -3, and it has a y-intercept at 0, 6, which can be seen here as the c value is 6.
Alright guys, so I thought I'd hop in Desmos to give you guys a better idea of what I meant when I said the parabola gets vertically compressed and vertically stretched. So here I have a parabola with just arbitrary values. Well, what's important here is this a value, right? So as you can notice when the a value is more than 1, it's almost like the graph is getting stretched upwards, right? So that's why we say the graph is vertically stretched, right? Now, if I make, went too far. If I make the a values less than 1, you can notice how it's almost like it's being pushed on from the top, like it's getting compressed. So that's why we say the graph gets vertically compressed. And as you may know, if it's in the negatives, then the graph opens down, right? So hopefully that gave you a better understanding of what I meant by vertically stretched and compressed.
Now I'll be taking a look at the factored form. So this right here is an equation of a parabola written in the factored form. Notice there's the a again, and this a essentially just gives you the exact same information as it does when it's written in the standard form. So the factored form is useful because it allows us to easily identify the zeros, which are the x-intercepts of the parabola. So R1 and R2 here are both the x-coordinate of the x-intercepts of the parabola. So to give you a better example, to give you a better idea, let's look at these examples. So this right here, this equation, x minus 4, x minus 6. So this parabola has zeros at 4, 0, and 6, 0. Since R1 is 4 and R2 is 6. The second example here, x plus 2, x minus 3. This parabola has zeros at -2, 0, and 3, 0. The reason why the x-coordinate of the 0 is -2 is because here shows up as +2, right? And in the original equation, it's x minus the 0. Since double negative equals positive, you could essentially think of this as x minus -2, which was just simply rewritten as x plus 2. So that's why it has a 0 at x minus 2. Finally, I'll be taking a look at the vertex form. So the vertex form, as the name implies, allows us to identify the vertex of the function. So the vertex of the parabola is written as hk, where h is the x-coordinate of the vertex and k is the y-coordinate of the vertex. So h and k. The a value here gives you the exact same information as it does in the first two forms. So for example here, this equation right here, this parabola right here, has a vertex at 5 and -7, since the h value is 5 and the k value is -7. The second example here has a vertex at -3 and 4, since it has an h value of -3 and a k value of +4. All right, now I'm going to take a look at how to convert from standard form to factored form. So let's see here. Question 1. Here we have an equation of a parabola in the standard form. So 2x squared minus 4x minus 30. So here you can notice you can easily factor out this 2 here. Whenever possible, you want to factor out the leading coefficient. It just makes your job a lot easier. So I'm going to start by factoring out this 2 here. Okay. Now, what you want to do here is find two numbers that multiply to this negative 15 here. So multiply to negative 15 and add to minus 2. So always you find numbers that multiply to the C value and add to the B value. So taking a look at these two numbers, you will realize that the two numbers that you need to find are minus 5 and 3. So what you do now, you leave the leading coefficient because you factored that out. You want to go x minus 5, then x plus 3. So essentially you take the two numbers that you found here, and you go x minus the first number, x plus the first number. You always keep the sign of the numbers here. Sorry for confusing you, but this was x plus 5, for example, it'd be x plus 5. So you always keep the sign of the numbers. And yeah, that's pretty much it for this question. So this equation written in the standard form is just 2x minus 5, x plus 3. All right, let's look at question 2 here. This is a slightly harder question since, as you may have noticed already, you can't easily factor out this leading coefficient here without having fractional numbers. So what you want to do here, the thought process is quite similar. Remember how in the first question here, you have to find a number that multiplies to the negative 15? Well, imagine that in front of this x here, there was a 1. So essentially, you have to multiply the coefficient of the a term and the c term. So 1 times negative 15 is negative 15, right? Well, here, since the coefficient isn't 1 anymore, you'd have to do 3 times 20. So the coefficient of the a term times c. So that would be 60, right? So you'd have to find two numbers that multiply to 60 and add to the, again, the coefficient of the b term and add to negative 19. So think about it for a bit. And the two numbers are negative 4 and negative 15. So what you do here is a bit different. Once you find those two numbers, you're going to want to expand this middle term. So you're going to go 3x squared minus 4x minus 15x plus 20. So essentially what you did here is you expanded this negative 19, or rather you separated it to this minus 4x and this minus 15x. So what you're going to do here, you're going to essentially try to split up this equation down the middle and look at it like you have two separate groups. So I'm going to start with this first group here, so the 3x squared minus 4x. And what you're going to want to do is you're going to want to factor out something, anything, right? So here I noticed that, oh, look at that, I could factor out an x. So I'm going to factor out the x. That's going to leave me with 3x minus 4, and then x outside the bracket. I'm going to repeat the same process for the second half of the equation, so the negative 15x plus 20. So here I notice, look at that, I could factor out a negative 5. So I'm going to do that, and that leaves me with negative 5, 3x minus 4. Now, here's a trick that you can use. If you did this step properly, or these two steps rather, you're going to notice that these two brackets are going to be the same. So if you did it correctly, they're going to be the same. If they're not the same, then that means you messed up somewhere. So you might want to go back and check your work. So what you do here is you essentially clean up the equation. So these two simply become one bracket. And you take the coefficients in front of both of these brackets and you put them into one, just like that. And that is the factored form of this equation right here. So a bit more tricky, but still doable. One thing I forgot to mention earlier is, in fact, how you find the zeros of the parabola now that you have the equation in the factored form. So I'm going to use question 2 here again. What you're going to want to do is you're going to take each of these brackets and you're going to set them both to 0. So you go 3x minus 4 equals 0, then x minus 5 equals 0. And then you're going to solve algebraically. So 3x equals 4, x equals 4 over 3, and this is simply x equals 5. So the zeros of this equation are 4 over 3, 0, and 5, 0. And yeah, that's how you find the zeros from the factored form. Okay, now I'm going to be teaching you guys how to go from standard form to vertex form. So this is done through a process called completing the square, and be warned, it's a little bit more tricky than going from standard to factored form. So what you're going to want to do, you're going to have your equation in standard form, right? What I like to do is I like to set the equation to 0. And then what I do is I move the coefficient, the c value at the end, onto the other side. And this just makes your life a little bit easier when solving. So what you're going to want to do now is you're going to take the coefficient of the b value here. So in this case, it's the 6, right? And you're going to go b divided by 2 squared. So in this case, it'd be 6 divided by 2 squared, 3 squared, which is 9. So you have this 9, right? Then you're going to come here and you go x squared plus 6x plus 9, right? And whatever you do when solving equations, remember, whatever you do to the left side, you have to do to the right side as well. So it's going to go 5 plus 9. So what you have here is a perfect square trinomial. So what you are allowed to do is take the c term here, technically, so in this case, the 9, and you're going to want to square root it, right? So I square root this 9, I get x plus 3 squared. Always remember that the sign here is the sign in front of the coefficient of the b value. So plus becomes plus here, right? That doesn't change. You have this, 5 plus 9 is 14. Now we're almost done. I'm going to bring this 14 over. So x plus 3 squared minus 14 equals 0. And that is this parabola standard form to vertex form. So here, the vertex would be at minus 3 minus 14. Okay, now let's say you want to go from vertex form to standard form. So, make a little section here. You basically just want to expand this and collect like terms. So x plus 3, I'm going to rewrite the equation quickly, equals 0. So I'll expand this. So I'll expand that using FOIL. X squared plus 3x plus 3x plus 9 minus 14 equals 0. So that becomes x squared plus 6x minus 5 equals 0. And just like that, you are back at the standard form. Okay, I'm going to do one more example. So basically, you're going to want to do the same steps as last time. So I'm going to start by setting the equation to 0. 2x squared minus 8x plus 9 equals 0. And taking this 9 and putting it on the other side equals minus 9. And as you can see here, you probably noticed already, you can factor out this 2. So that's exactly what I'm going to do because it makes your life a whole lot easier. It's minus 9. And now at this point, you're going to want to do the b over 2 squared. So you're going to take this minus 4, which is your b, divided by 2 squared, which is negative 2 squared, which then becomes 4. So then you're going to go 2x squared minus 4x and add that negative 4 right there. And remember, whatever you do to this side, you have to do to this side as well. So I'll go like that, plus 4. But here, make sure you don't make this mistake. Since we factor out this 2 here, when you bring out this 4 to the other side, you have to multiply by the 2 since you're essentially taking it out of the bracket. So this becomes negative 9 plus 4 times 2. So let me so negative 9 plus 8. So just be aware of that. So now we have a perfect square trinomial here. So what I'm going to do, I'm going to take this 4 and square root it, which comes to 2. Have that all squared, equals minus 1. Now remember what I said in the first example, this minus sign just gets put straight down there. So whatever is in front of the b is the sign that is going to be in the bracket, okay? So now you're almost done. You're gonna wanna bring that 1 over, equals 0, and that would be your final answer. That is the equation in the vertex form. And so the vertex is at 2 and 1.